Hello friends, welcome to Susan and John MathTube. We are in lesson number 12 in the examination preparation series for first year engineering students. And we are still on properties of definite integrals. And in this video, we'll again go through a few more very important questions. Okay, but before we start, I want you to give a small background so that most of the students will feel comfortable when we do that actual question. So point number 1, you can note these things. If you are not that comfortable with integration, it's better that you note these things. Okay, so the trick is creating a Pythagorean triplet. Pythagorean triplet is very useful to convert expressions in the form a sin x plus b cos x into sin a plus b format. Anyway, this is a very special case. Normally the Pythagorean triplet means a, b and the number root under a square plus b square, because this will be always the sides of a right angle triangle. Anyway, this a and b actually stands for the coefficients of sin x and cos x. And here the coefficients are 1 and 1. So the triplet will be root under 1 square plus 1 square, and that will be root 2. Now what I do is I am going to multiply and divide by root 2, so that I end up with something like this. Anyway, this 1 by root 2 is a special number, and I'm sure that most of you know how to convert this 1 by root 2 into sine and cos. Anyway, cos 45 degree as well as sine 45 degree is 1 by root 2. Okay, so I'm going to manipulate this a little bit. I'm going to write this as sine x. I'm writing the same thing, and instead of 1 by root 2, I'll write cos 45 degree plus cos x into sine 45 degree. 45 degree means pi by 4. I think you are able to see a formula which you have learned in your younger classes. What is sin a cos b plus cos a sin b? Sin a plus b. Okay, so this is point number 1. So what we just learned is how to convert sin x plus cos x into the form sin of a plus b. Okay, now point number 2. Point number 2 is something very simple for most of you. 1 by sin theta is cosec theta. By the way, do you know, if you look at American books, you may not see a function called cosec theta. They simply use CSCX. You can check the American books or Google about it. Yeah, so basically it's the same thing. And the next thing is integral cosec theta d theta is equal to log cosec theta minus cot theta plus c. There is an equivalent form, but I love this form, so if you want, you can note this. And a few more things. Cosec 90 plus theta, that means it will be in the second quadrant, and that is sec theta, and cot 90 degree plus theta, and that will be minus tan theta. That's more than enough, and let's go for the problem. Okay, so please write, evaluate the definite integral I is equal to integral 0 to pi by 2 sin square x the whole divided by sin x plus cos x dx. Okay, so as always, now we have done so many lessons based on this. Even though the last videos were very small, we have already done a lot of problems. So I'm going to call this as equation 1. And you know the method. If you have integral 0 to a, you're supposed to replace the function with f of a minus x, and we learned both are same. So what I do in the next line is I write this as integral 0 to pi by 2 sine square pi by 2 minus x, the whole divided by sine pi by 2 minus x plus cos pi by 2 minus x times dx. And you know what is sine 90 minus x? Yeah, sine 90 minus x is equal to cos x. And what about cos 90 minus x? That will be equal to sin x. Now if you replace this 90 minus x with all these things, you're going to get I is equal to integral cos square x dx, the whole divided by, actually this will become cos x plus sin x, it's the same thing, that's sin x plus cos x. And I'm going to call this as equation number 2. And the limits are same. Okay. And now let's add equation 1 and 2. Can you tell me what will happen if I add 1 and 2? Yeah. 2I is equal to, the integral is common. And you might have noticed the denominator is also common. No, I'll do one thing. I'll just write that over here. Sin square x by sin x plus cos x plus cos square x by sin x plus cos x, and finally dx. So look at this, we have a common denominator, and the numerator is sin square x plus cos square x. What is sin square x plus cos square x? 1. So I end up with integral 0 to pi by 2 1 by sin x plus cos x. Now I think you're able to associate this with the introduction I gave you today. Let's go and check it. So I told you in the beginning, sin x plus cos x can be manipulated by multiplying by root 2 and writing that 1 by root 2 as cos 45 and sin 45 wherever we need, and final product will be this. Okay, so I'm not going to do that again. So in your exam, you can do that in one corner. You can make a box and write sin x plus cos x is equal to root 2 into 1 by root 2 sin x plus 1 by root 2 cos x, and that will be root 2 into sin x cos 45 degree plus cos x sin 45 degree. I'm not going to write that neatly, I already showed you what's going to happen. So basically you're going to get sin x plus pi by 4. That's it. So I'm going to write this as sin x plus pi by 4. If you didn't understand this properly, I will ask you to rewind a little bit and go for the first part. Okay, then I asked you what is 1 by sin theta. Do you remember in the introduction I told you what is 1 by sin theta? Exactly, cosec theta. So, okay, so those who did not understand this can rewind to the first part of the video and go through it once more. Anyway, I'm going to replace this with 1 by root 2 sin x plus pi by 4. Now I think you are able to associate with the introduction of this video, and this 1 by root 2 goes outside. So I'm going to write 2i is equal to 1 by root 2 integral 0 to pi by 2 and 1 by sin theta, that will be cosec x plus pi by 4 dx. I think let's cross multiply and write I, that will be 1 by 2 root 2, and then I think you're ready to integrate. What is integral cosec theta? Okay, those who don't know, just pause the video, rewind and check the formula. Log cosec x plus pi by 4 minus cot x plus pi by 4 within the limits. Okay, now what we do is we plug in the upper limit. So we get log cosec. You plug in the upper limit here. I'll circle that with an yellow. Okay. So you're supposed to plug in the upper limit pi by 2 and pi by 2 plus pi by 4. There are two options. If you want, you can use the formula cosec 90 plus theta. And if you don't want to use that, just use your calculator and calculate this 90 plus pi by 4 will be 3 pi by 4 minus cot 3 pi by 4. You can use a calculator and evaluate it. So upper limit minus lower limit. Now I'm going to plug in this 0 over here. So I will get log cosec 0 plus pi by 4 minus cot 0 plus pi by 4. I will be 1 by 2 root 2. I'm sure you are smart enough to find these things. So eventually you're supposed to get log of root 2 plus 1. You can use any method you like. If you want, you can apply the formula 90 plus theta or use a calculator and do this directly. Anyhow, this will be the last answer. Okay, so that is 1 by 2 root 2. Okay, now tell me, what is log A minus log B? Yeah, log of A by B. Okay, now look at this. To be honest, we can leave it as such. But sometimes they will ask this as a prove that question. So let's learn to simplify this a little bit more. In the sense, we multiply this fraction by the conjugate. So I'm going to do like root 2 plus 1 times root 2 plus 1 by root 2 minus 1 root 2 plus 1. Sorry for that, I didn't put the bracket. Brackets are very important. Yeah, so 1 by 2 root 2 log, what is a plus b the whole square? Okay, we get root 2 plus 1 the whole square by, what about a minus b into a plus b? We get 2 minus 1, that's it. So we get I is equal to 1 by 2 root 2 log root 2 plus 1 the whole square. Now look at this. Log a to the power b, you might have learned this property in class 12, becomes b times log a. So this 2 jumps outside and we end up with 1 by root 2 log root 2 plus 1. Okay, let's try one more question of the same type. So please try the next question. Evaluate the integral 0 to pi by 2. Okay, so I want you to do this problem by yourself. I think now you'll be able to handle this. Let's discuss a few things which might be important for some of the students. So what is sine 90 minus x? Cos x. And what about cos 90 minus x? Of course, sin x. So we replace, we call this as equation 1 and we replace, and the numerator becomes pi by 2 minus x and the denominator will become cos x plus sin x. Eventually it becomes sin x plus cos x. So I skipped a few steps, but don't do that for the exam. In exam it's better to do the presentation with all the steps. Now let's write equation 1 plus equation 2. So what is this I plus I? 2i. And the integral is common. So the denominator is common. So you are going to get x by sin x plus cos x plus pi by 2 minus x by sin x plus cos x. At the last dx, of course I forgot dx over here, and you're going to get 2i. Look at this, the denominator is common, so this x and x will get cancelled eventually. So you get pi by 2 integral 0 to pi by 2 1 by sin x plus cos x. Now I think I don't have to continue. I think you remember the introduction. What will we do with this sin x plus cos x? Yeah. So make a box. Start. Sin x plus cos x. We multiply and divide by root 2. And then we manipulate 1 by root 2 into blah blah blah, etc. But don't stop. As a student, it's better that you work out the problem again and again and again so that you're confident. Anyway, you can pause the video right now and continue. Okay, so I hope you got the answer for the previous question. Okay, now another very important question. And that is actually evaluate. To be honest, I should have done this question only after teaching you improper integrals. Anyway, I'll correct you with a few concepts later on. For the time being, you can start. Okay. So the question is evaluate the integral, or another version is prove that this integral is equal to pi squared by 2ab. Please note this question, because if you are not familiar with the question, you might make serious mistakes in the exam. I'll repeat once more. This question should be done only after we learn improper integrals. Anyway, I'll do those corrections later. Let's go ahead with the process. So, the first thing I want you to know is, you can note the background. Suppose you have an integral in the form 1 by L sin square x plus m cos square x plus n. You might have learned this as a standard type in class 12. The method is multiply throughout by 1 by cos square x. 1 by cos square x means sec square x. So you multiply each and every term, the numerator and the denominator, by sec square x. And when you multiply the denominator, you might encounter with sin square into sec square. And note that sin square into sec square is actually sin square into 1 by cos square. So you end up with tan square. And then you might be forced to multiply cos square and sec square. That is good news, because they are reciprocals. The sec square is actually 1 by cos square, so you are going to get 1. And finally, you will multiply this with n, so you get n into sec square x, and you must convert the denominator completely into tan square x. So remember, you multiply, whenever you get a problem in this format, you multiply each term in the numerator and denominator by sec square x. And don't forget, you have to write the denominator completely in terms of tan square x. And point number 3, that is, you put tan x is equal to t and proceed. So shall we start? Yeah. So I'm sure you're familiar with questions like this. So let's start with the left side. So I'm going to give it a name and I'll erase this. Yeah. So what's the first thing to do? Yeah, as always, call it equation number 1. Now I'm going to replace x with pi minus x, and you know what's going to happen. Anyway, I'll write a few background notes here. What is sine 180 minus x? Second quadrant, sine is positive. And what about cos 180 minus x? Minus cos x. But wait a minute. We are squaring these things. We are actually talking about the square of these things. So eventually you're going to get the positive answer. So you're going to get a square sine square x plus b square cos square x. Warning, I skipped a few steps. Okay, but that's not going to harm you, provided you're watching my videos from lesson 8. Okay, so now the next thing to do is equation 1 plus 2. So tell me, what is I plus I? Yeah, 2i. So we get 2i is equal to integral 0 to pi. Again, we have common denominator and the numerator becomes pi. That is obvious now because you're quite familiar with a lot of problems like this. Okay, now let's start. So I get 2i equal to integral 0 to pi. The numerator is pi, so I put it over here. 1 by a square sine square x plus b square cos square x dx. I hope you remember the introduction I gave you. Whenever you have a standard integral like this, the first thing to do is multiply throughout by sec square x. I think it's time to write I is equal to pi by 2. Okay, now shall we multiply? Okay, so we get sec square x the whole divided by, I told you in the beginning, sine square into sec square will be sine square by cos square, that is tan square, plus b square into 1. There is a property which I did not discuss in lesson number 8. Suppose we have a function, let's say a function like this, and let's say this is 0, this is a, and this is 2a. That is, this is periodically moving in this manner. And if you integrate from 0 to 2a, and remember, this is kind of symmetric. So the function keeps on popping up like this. So integral 0 to 2a f of x dx in this case will be 2 times integral 0 to a f of x dx. I hope you still remember what is integration. What's integration? Addition. Addition of these function values, addition of all these heights. Since this sum, the sum of all the heights here and all the heights here are the same, I'm able to write, look at this, I have to add from 0 to 2a, but I'm doing half the job and doubling. And this can be done only if the graph appears like this. And the condition is very simple. You use f of upper limit minus x and you should get f of x. Okay, so look at this. I'm going to take this function and check that property. 6 square pi minus x by a square tan square pi minus x plus b square. Of course, it will be the same because you're squaring and it's like 180 minus theta, so there will be no change. So what I'm trying to convince you now is, we have the limit from 0 to pi and the midpoint is pi by 2. And I know we are allowed to apply the property. So what I do in the next line is, I'm going to write pi by 2 into 2 times 0 to pi by 2 sec square x by a square tan square x plus b square. Now look at this, my friends. This is a key step. If you forget this, you're going to end up with the wrong answer. This is very, 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 very important. You'll understand later on why I did this. Because if I, do you remember the method? First we multiply by sec square x. And then you write the denominator in terms of tan square x. And finally you'll put tan x is equal to t. When you put tan x equal to t without changing, you will end up with 0 to 0, which will give you the wrong answer. Is that clear? Okay, so now my integral looks like this. Pi times 0 to pi by 2 sec square x dx, the whole divided by a square tan square x plus b square. Okay, now let's start with the standard process. Put tan x equal to t. So sec square x dx will be equal to dt. And time to change the limit because this limit belongs to x. So this is actually x equal to 0 to x equal to pi by 2. So t is equal to tan x, isn't it? You just read this from right to left. So when x equal to 0, t will be tan 0. And when x equal to pi by 2, t will be tan pi by 2, that is infinity. Okay, so we get integral t equal to 0 to infinity. The numerator will become dt by a square t square plus b square. Okay, so now I have to give you one warning. I told you I should have done this problem only after teaching you improper integrals, because whenever we have infinity in the limits, we call that integral improper integral. Anyway, let's move ahead. After one or two more videos, we will be discussing how to deal with this kind of integrals. Okay, so I is equal to pi, and now let's integrate. Before we integrate, I'll ask you one question. What is integral at the whole square plus b square? Okay, I'll give you a few formula. First of all, you have to understand the derivative of tan inverse x is 1 by 1 plus x square. So integral 1 by 1 plus x square is equal to tan inverse x. Please mind that dx. Now integral a square plus x square will give you 1 by a tan inverse x by a. And now 1 by a square plus, let's say, bx the whole square dx will give you 1 by a into b tan inverse bx by a. If you know this, it's easy. Otherwise, we have to take that common factor, etc. Anyway, I'm going to apply this directly. For the time being, the limits are 0 to infinity. So we get 1 by a into b tan inverse at by b within the limits t equal to 0 to infinity. Anyway, I am not going to show the next few steps. Tan 90, all I am going to tell you is tan 90 tends to infinity. So you can guess what is tan inverse infinity, and tan inverse 0 is 0. So you end up with the final answer pi by, and then there will be one more pi, so you get pi square by 2ab. I'll repeat once more. I have to teach you something called improper integrals later on. Okay, so I'm going to wind up this video right now, and I think in one more video we'll be able to discuss all the important questions related to properties of definite integrals, and slowly we have to move on to the next topic, that is improper integrals. So till then, my friends, bye. And if you have doubts regarding this topic, you can email me or you can contact me directly from my website. Visit the website www.sjmathtube.com, because you will see the first year engineering topics in a list. It is like well arranged, so you will find it very easy to find the topics. Okay, so we will meet very soon in the next video.